Well, what we see here is that the mathematics appears to work. Just using a 0.02 second increment, we got something around 0.14 seconds. Maybe a little more than 0.14 seconds, but maybe this is an overestimate. And of course, there are some uncertainties in measuring the 6 millimeters especially. Okay, if I was off by half a millimeter in measuring the 6 millimeters, well, that's about a 10% error. So I could have a 10% error in this, which would lead to a 10% error here and a 10% error here. So if there's a 10% error, this might be as little as 0.125 seconds and as much as 0.152 seconds. Actually 124 to 152. So there's a pretty wide range of what this might really be. I think it was pretty close to 6 millimeters. I don't think it was a 10% error, but I would say that this is probably accurate within a 0.01 seconds. So we're between 0.128 and 0.148. I'll also say that when this thousandth of a second process is completed, I believe we hit 0 in 0.128 rather than 0.138 seconds. So the prediction of this model, which should be pretty darn accurate, is just barely within the range of what I thought my uncertainty would be here. Now there are other little uncertainties that maybe add to the uncertainty in this estimate, in this result from the experiment. But it seems that the mathematics agrees with the real world. And remember that the mathematics is based on how we calculated alpha, the rate at which our angular velocity changes. Remember, we calculated that as negative 300 cosine theta with some appropriate assumptions about the units. Now, that's really what physics predicts, and I think that's probably pretty close. But also remember, the domino might be slipping a little bit. There are other things that might be going on that we haven't accounted for. So to be this close with the theoretical prediction and the actual measurement is really pretty good confirmation. Again, pretty good confirmation of our experimental process, pretty good confirmation of our mathematics. It doesn't prove anything, okay? We have to do more refined experiments to prove things a little more believably, but it does appear that maybe we're on the right track with all this. And remember, some of you went out and looked up angular momentum and moment of inertia and all that kind of stuff, okay? And that was really good, and you came up with some really good stuff. Now, you've got to know a little more physics to put it together, and I'm going to try to do a video on that. But that turns out to be pretty good confirmation of the physics also. The experiment is consistent with the theory.